Hello everyone, good evening everyone. Is everything fine? Audio video? Is everything fine? Audio video? Good evening everyone. Good evening Vijay Sharma, Urtika, Oma, Vijay. Good evening everyone. Is everything fine? Audio video? Please post your comments. Right. So in this session we are going to discuss gate through questions for algorithms for the GATE 2026. So I will try to cover approximately 20 questions. So 2-3 questions related to one topic, and it covers almost all the topics. So some can be the basic question, some can be the more conceptual question. I includes more MSQs and numericals rather than MCQ, because many times student asks that we need more practice questions for MSQ. So maximum questions are MSQ and numerical questions. So just for good practice. And sometime question not just about the answer, it's about basic concept. Okay, some basic concept. It's like a revision of the core concept. Okay, so hope you all everything audio video everything fine. Okay, let's start. The first question, it is about the asymptotic notations. Is everything fine? Font size and all. About the asymptotic notations, if limit n tends to infinite f of n by g of n is 0, then limit n tends to infinite log f of n by log g of n also 0. Okay. So MSQ question, if limit n tends to infinite f of n by g of n is constant, which is greater than 0, okay, then limit n tends to infinite log f of n by log g of n is constant. Okay, if limit n tends to infinite log f of n by log g of n is 0, then limit n tends to infinite f of n by g of n is 0. If limit n tends to infinite log f of n by log g of n is constant, then limit n tends to infinite f of n by g of n also constant. Okay, just 1 minute, post your comment. How is preparation? So please revise all material related to the algorithms, class notes which we studied in MedEasy offline or online classes is more than sufficient, and solve the PYQs. Okay, just revise the notes multiple times. So there is no chance to go question beyond the class notes, right? Linked list, it's a algorithm session. It is done in the data structures, linked list related questions. Okay. It is MSQ question. Right. Okay. So hope you remember this one. So limit n tends to infinite. Limit n tends to infinite f of n by g of n. Limit n tends to infinite f of n by g of n. Okay, limit n tends to infinite f of n by g of n. 3 cases, f and g non-negative functions. F and g non-negative functions. Okay, so if it is 0, f of n asymptotically smaller than g of n. F of n asymptotically smaller than g of n. If it is constant, f of n asymptotically equal to g of n. Okay, if it is plus infinite, okay, f of n asymptotically greater than constant. Sorry, f of n asymptotically greater than g of n. Okay, so this is the, if f of n g of n non-negative function, okay, limit n tends to infinite f of n by g of n is 0, constant or plus infinite. G of n asymptotically bigger, asymptotically equal, f of n asymptotically greater. So what he says, what he mean to say here, limit n tends to infinite, f of n by g of n is 0. 0 means g of n asymptotically bigger. So if f of n asymptotically smaller than g of n, f of n asymptotically smaller than g of n, then so limit n tends to infinite log f of n by log g of n, so is also 0, he says that. It means that log f of n must be asymptotically less than log g of n. True or false? Okay, is this true or false? This is the meaning of the first statement. Okay, so f of n asymptotically less than g of n, log f of n may not less than log g of n, may become equal also. Okay, log f of n may become equal also, it can be less than or it can be equal. For example, if it is n cube less than n power 5, n cube less than n power 5, but log f of n 3n cube, log g of n 5 log f of n 3 log n 5 log n asymptotically equal. So f of n less than g of n, f of n less than g of n, log f of n can become either asymptotically less than or asymptotically equal. Okay, either it is asymptotically less than or asymptotically equal, not guaranteed only asymptotically less than. Okay, it can be asymptotically equal also. So this, because of that, first statement is false. He says that log g of n is asymptotically bigger, may equal also. F of n, limit n tends to infinite, f of n by g of n is constant. Okay, if it is constant, okay, it means that f of n g of n asymptotically equal, f of n asymptotically equal to g of n, then log f of n also asymptotically equal to log g of n. Log f of n also asymptotically equal to log g of n. Okay, right? Okay, hope you cleared this one. So this B is correct statement. Okay, then log f of n, limit n tends to infinite. Okay, log f of n by log g of n is 0. It means the third option. It is log f of n if asymptotically less than log g of n. Log f of n asymptotically less than log g of n, then f of n is limit n tends to infinite, f of n by g of n is 0. F of n asymptotically equal to g of n. So f of n, sorry, it is f of n also asymptotically less than g of n. This is true. If log f of n already smaller than log g of n asymptotically, the corresponding function f of n also asymptotically smaller than g of n. Okay, so next, log f of n, limit n tends to infinite, f of n, log f of n by log g of n constant. It means that log f of n, log of f of n asymptotically equal to log of g of n, log of g of n, then f of n and g of n may not asymptotically equal. F of n, g of n may not asymptotically equal. May not asymptotically equal, right? So this log f of limit n tends to infinite, f of n with g of n constant may not be true. So D is also false. Answer to this question is option B and C. Okay, right? Sir, stories of NIT Warangal. Okay. C is also correct, right? Is this fine? Right, let's move to the next question. Okay, this is previously comparison between f and g versus log f log g. Now comparison between f and g versus 2 power f and 2 power g. Comparison between f and g versus 2 power f and 2 power g. Okay. So asymptotic comparison between 2 power f and 2 power g versus f and g. Okay, f of n and g of n and 2 power f of n, 2 power g of n. Answer this. Right. Okay. So did anyone done this question? Make it fast. It is not about question to answer, try to understand concept also. Okay, each question involves so many multiple basic concepts. Okay, see, if f of n asymptotically less than, strictly less than g of n, asymptotically less than g of n, okay, then 2 power f of n, 2 power f of n is also asymptotically less than 2 power g of n, because g itself asymptotically bigger, 2 power g is means that g of n in the power side, okay, that f of n asymptotically smaller, okay, 2 power f of n guaranteed asymptotically smaller than 2 power g of n, okay. Okay, similarly, if 2 power f of n asymptotically equal to 2 power g of n, okay, 2 power f and 2 power g asymptotically equal, okay, then f and g is also asymptotically equal. F and g is also asymptotically equal. So f and g is in the power side. F and g in the power side. Still 2 power f and 2 power g is equal. That means f and g, okay, so just constant addition, constant subtraction can be different, not even constant multiplication factor. Okay, so that means this f of n can be something like 2n plus 1. And g of n can be something like only 2n. Okay, so then this kind of functions are exist, only constant addition or subtraction difference, not multiplication also, 2 power f of n, 2 power g of n asymptotically equal, then f and g is also asymptotically equal. Okay, these two are all only straight statements. Then after that, the next two statements, for example, f is asymptotically equal to g of n, f of n asymptotically equal to g of n, okay, then 2 power f of n, 2 power f of n, 2 power g of n may not asymptotically equal, may not asymptotically equal. So because if f is constant time bigger than g, 2 power f become asymptotically bigger than 2 power g, g constant time bigger than f of n, 2 power g of n become asymptotically bigger than 2 power f of n, f and g is, okay, asymptotically equal with multiplication factor of same constant, then 2 power f and 2 power g can be equal also. Okay, then what is the next one? So f less than g, like assume next 2 power f, okay, so if f is 2 power f less than 2 power f of n less than 2 power g of n, but f and g may not be asymptotically equal. To f of n may not be asymptotically less than g of n. Okay, f of n and g of n can be asymptotically equal also. Okay, f of n and g of n can be asymptotically equal also. F of n can become asymptotically equal to the g of n or asymptotically less than g of n. Asymptotically equal or less than g of n. Okay, these are the 4 statements related to comparison between 2 power f and 2 power g versus f and g. Okay, so f of n omega of g of n, it means greater than equal. F of n asymptotically greater than equal. Okay, f of n asymptotically greater than equal. If f of n asymptotically equal to g of n, 2 power f of n may not be equal. 2 power f of n may not be equal. There may be a chance that 2 power g of n can be bigger. Okay, so by the time of asymptotic equal function with g of n constant time bigger, by the time of asymptotic equal function with g of n constant time bigger, this statement is false. Okay, this statement is false. F of n asymptotically equal to g of n, asymptotically equal to g of n, 2 power f of n, 2 power g of n may not asymptotically equal. If f of n constant time bigger, okay, then 2 power f of n asymptotically bigger than 2 power g of n. G of n constant time bigger, 2 power f of n less than 2 power g of n. F of n, g of n asymptotically equal. Okay, with including multiplication times, multiplication of constant times, both are equal, exact same functions. Okay, then 2 power f of n can become equal to 2 power g of n. So that's why this statement is also false. Now f of n asymptotically less than equal to 2 power f of n asymptotically less than equal to 2 power g of n. Okay, then f of n also less than equal to g of n. For example, if 2 power f of n less than 2 power g of n, then f of n also less than g of n. Okay, sorry, if 2 power f of n less than 2 power g of n, less than 2 power g of n, so f of n is okay, f of n and g of n may not asymptotic equal, right? So just see this one, 2 cases here. For example, 2 power f of n, if asymptotically equal to 2 power g of n, then also f of n, g of n asymptotically equal. F of n and g of n asymptotically equal. Then the other possibility, if 2 power f of n asymptotically less than 2 power g of n, asymptotically less than 2 power g of n, then also f of n asymptotically less than g of n. Okay, it's a combination of first and second statement, so it is a true statement. Okay, then 2 power f of n asymptotically equal to 2 power g of n, f of n and g of n also asymptotically equal. So C and D, answer to this question is C and D, right? Vijay, very good. Sneha, Nitish, just check it once. A is false statement. C and D, got it. Vartika. Right? So it's not about the question to answer. This the comparison between f of n and g of n versus 2 power f and 2 power g. Okay. So many times the same concept repeats in competitive exams. Right? Shall we go to the next question? Is it fine? Yes. So asymptotic notations. So last 3-4 years after MSQ begins, almost one MSQ question or one MCQ question is from asymptotic notations. Okay, in the GATE patterns. Okay, So please practice asymptotic notations properly. So all proper rules and rules of the asymptotic notations, one important area. Most probably there is a chance 1 more 2 marks MSQ question from the asymptotic notations, right? Next, so simple recursion. First one is simple recursion. Okay, so algorithm recursive of n, if n less than equal to 1 return, else return recursive of n minus 1 plus 1 by n. Okay, assume complexity to find 1 by n value, complexity to find 1 by n value, okay, for a given n is constant. That means constant time complexity to find 1 by n, to find 1 by n, to compute 1 by n. So calculation cost is constant. Okay, I am not saying 1 by n is constant. To compute 1 by n value, okay, the calculation cost is constant, is given. So which is R? Okay, again MSQ question, which is R correct for given recursive algorithm? Okay, time complexity of this recursion is log n, return value of the recursion is log n, time complexity of recursion is n, and time complexity of recursion is n log n. So good evening, get up. So tomorrow DBMS 6 to 9 or 6 to 8:30 depends on, okay, so your interest. Okay, so tomorrow we will discuss the DBMS GTQ. Yeah, Sneha, Nitish. Okay, so first let us write the recurrence equation for time complexity. Assume T of n is time complexity recurrence equation. T of n, so n less than equal to 1 it is constant. Okay, in the else part recursive of n minus 1 is there, which require T of n minus 1 time, and the remaining computation cost 1 by n computation cost and adding the remaining cost is constant. Remaining computation cost is constant time to compute this. Okay, so that means the recursion T of n minus 1 plus constant. Okay, so apply substitution method. So the time complexity is order of n. If excess cost taken by each recursion is constant, time complexity equal to number of recursive calls. Number of recursive calls is Q tree of n levels, n recursive calls required, each recursive call required constant time. So the total time complexity is order of n. So time complexity of this is order of n. Then the return value, this T of n is the time complexity. Time complexity of recursive of n. Return value it is returns. It returns T of n minus 1 plus 1 by n value. Okay, the value it returns T of n is subrecursion returns, okay, T of n minus 1 plus 1 by n added to the value of recursive of n minus 1. Okay, this is become return value. Okay, this is not time complexity, it is a return value of the recursive of n. Return value of recursive of n, right? So if we apply substitution method, so T of n minus 2, okay, plus 1 by n minus 1 is T of n minus 1 value plus 1 by n. Okay, it is, okay, series of 1 by n minus 1 up to so on, okay, constant. Okay, so that means the series is 1 plus 1 by 2 plus 1 by 3 plus up to so on plus 1 by n. So the return value is theta of log n. Okay, return value of the recursive of n is theta of log n, BC. Right? D is not correct. Time complexity not n log n and time complexity not log n. Sorry, the D is also time complexity is n. It is a big O of n log n. Big O of n log n. So n asymptotically smaller than big O of log n. Big O of n log n. So because of this big O representation, D also correct. Okay. So answer to this question is BCD. D correct, right. Okay. So no need to fear. Okay. So Nitish, see, it's a all India exam. Everyone means how much hour we study, we feel like still we are not done up to the mark. Okay, that is a common problem for every student. Okay, so just try your best, and that fear obviously should be there, but that should not that fear should make you work more. Okay, because of that fear you should wake up early and study, focus with full focus and all. Okay, so that fear, if it is damaging your productivity, then it's unnecessary, become negative impact. So obviously fear should be there. Okay, that fear should do the work as best as possible, right? Okay, no need to fear, just do it. Right, next this is also next question also recursion only. Next question also recursion only. Okay, master theorems, recurrence equation, apply master theorem, match the following. Okay, T of n is 8t of n by 4, n by 64 plus root n by log n. Okay, so T of n is 8t of n by 32, root n multiply with log n. Okay, so T of n is T of n by 2 plus log n. T of n is T of n by 64 plus 1 by log n. Apply master theorems. All recursions can solve by the using master theorem. Apply master theorem and solve the question. Right? Vijay given answer A. Gauranshi answer D. Right? So now first one. So A8 and B 64. N to the power of log 8 base 64. N to the power of log 8 base 64. So log 8 base 64 is root n. Okay. So that means n to the power of log a base b, n to the power of log 8 base 64 is one function, then f of n function is root n by log n. So it is also root n, okay, root n and root n asymptotically equal, asymptotically, sorry, the means a polynomially equal, asymptotically not equal. This f of n is okay, so log n times smaller. This is f of n and this is assume n power log a base b, n power log a base b. F of n is log n times smaller. Okay, so if f of n is log n times smaller, then this is modification of the second case, then T of n solution is theta of n power log a base b, that is root n multiplied with log n, root n multiplied with log n, okay, is the solution for this recursion. Okay, is the T of n asymptotic value. Okay, that means this first one root n log n 1 4. Okay, next the second one n to the power of a 8 and b 32. It means n to the power of log 8 base 32. Okay, n to the power of log 2 cube base 2 power 5. So this is 3 by 5. Okay, n to the power of 3 by 5. Three by 5 is n to the power of 0.6. Okay, so f of n is this f of n. This f of n is root n multiplied with log n. That means this is asymptotically polynomially bigger because n to the power of 1.06, 0.6. This n to the power of 0.5. This n to the power of 0.6 polynomially bigger. So polynomially bigger. So n power log a base b polynomially bigger. That means T of n solution is okay. So is theta of n power log, okay, so 8 base 32, it means n to the power of 3 by 5, n to the power of 3 by 5, it is 0.6, n to the power of 0.6. That means the second one is this one, okay, so 2 1. So 1 4 and 2 1, right, option A. Now okay, 1 4 and 2 1, right, two more options are matching so far. So f of n is okay log n power log a base b. So here n power log a base b, n power log 1 base 2, okay, log 1 base 2, okay, log 1 base 2 is 0. This is n power 0 constant. The f of n function, this f of n function is log n. So both are, f of n is log n times bigger. If f of n log n times bigger, it is comes under modification of case 2, n to the power of log a base b 1 multiplied with log n to the power of k plus 1. So k 1 the condition true, it is log n whole square. Okay, that means 3 2. Okay, 3 2, and this is also okay f of n power 0 is 1 by log n times smaller. That means T of n is theta of n log n to the power of log 1 base 64 0, n to the power of 0 multiply with log n. Okay, it is modification of the case 2. So option A is the correct answer, right? So MST wala question means whole subject has to be covered na. MST also 2-3 questions are there. Okay. In spanning tree and minimal spanning tree, and minimal spanning tree, If you remember, before starting spanning tree, we discussed a lot of concept related to spanning tree. So the concept related to spanning tree and computing number of spanning trees, and the if edges are distinct, what is the set of statements which are true for MST. Those all if you practice, which we done in the class, you will able to do MSQ question of minimal spanning tree or spanning tree. So almost 99% you will able to do, okay, with so confidently. Okay, so if sometime beyond the class notes some statement is given, you should take some example and try it. Okay, so just classroom notes of spanning trees and minimal spanning trees more than sufficient. We done a lot. Okay, so just it's a in algorithm. Okay, so we greedy algorithm, Prim's and Kruskal. So most of the cases in algorithm course, what they think, the spanning tree and minimal spanning tree means only Prim's Kruskal algorithm complexities. Okay, but exam point of view, Prim's Kruskal algorithm and complexity 10-20% only. Okay, 80% general questions about the spanning tree, about the minimal spanning tree, rules of the MST. So that we done so clearly in the class notes and practice. Okay, so multiple times. Okay, that's important topic. Today also we will see 2-3 questions, right? Next one. It is again recursive algorithm, MSQ question. Recursive of n, if n less than equal to 10, return 1, else return recursive of 9th root of n plus recursive of 9th root of n plus recursive of 9th root of n plus square root of log n base 9. Okay, so assume time complexity to compute square root of log n base 9 and n to the power of 1 by 9, 9th root of n is constant for any given n value. Okay, that means time required to compute this, time required to compute, then root log n is not constant or n to the power of 1 by 9 is not constant. Okay, time complexity to compute this value for a given n is constant. Okay, then what is time complexity of recursive of n? Number of recursive calls of recursive of n and space complexity of recursive of n and return value of the recursive of n. Done it? MSQ question. Okay. Now see, Sneha saying that ABC, but you can say C is a false statement. C is false. Okay, C is false statement because if recursion is 9th root of n, recursion 9th root of n, the depth of recursion is log n. Depth of recursion is log n. Okay, depth of recursion is log n, means stack space requirement is log n. So So the space complexity, okay, of the recursive of n, space complexity of a recursive of n, okay, it is n reduced to n to the power of 1 by 9, n to the power of 1 by 9 square, n to the power of 1 by 9 cube, up to so on n to the power of 1 by 9 power k is constant 10. So to get the k, we need to apply 2 times logarithmic. The space complexity of this is theta of log n. Theta of log n. He is saying theta, okay, it's not log n. Log n is the space complexity. So C is a false statement. Right? Now, what about time complexity? What about time complexity? See, the excess time taken by each recursion, for example, time complexity of recursive of n is T of n. Time complexity of recursive of n is T of n. Okay, assume that T of n is time complexity. Time complexity of recursive of n. Right? So, if n less than equal to 1 is constant time complexity. If n more than 1, 3 subrecursions, recursive of 9th root of n plus recursive of 9th root of n plus recursive of 9th root of n. Okay, this is t of 9th root of n or n to the power of 1 by 9, 3 subrecursions, and remaining, because computation cost of this is given constant, the remaining excess cost, to compute it is constant. If excess time required constant excess time, okay, is required other than subrecursions, then time complexity equal to number of recursive calls. Time complexity is same as number of recursive calls. Okay, so number of recursive calls, if you calculate number of recursive calls, okay, number of recursive calls is complete ternary tree, 3 subrecursions, complete ternary tree of depth log n. So it is complete ternary tree, 3 power of depth log n. So log n depth base, because of n to the power of 1 by 9. Okay, this, so first apply logarithmic with base 10, this inner base is 10 and this outer base is 9. Okay, so this is equal to log n to the power of log 3 base 9. Okay, log 3 base 9. Log 3 base 9 is root log n. Okay, this is root log n. Okay, so the time complexity, number of recursive calls, both are root log n. Okay, so number of recursive calls root log n is true, and time complexity is root log n is also time complexity should be root log n only. It is not root log n multiply with log n. A is also false. A false and C false. Then return value of the recursive of n. Okay, if T of n is value written by the algorithm, assume T of n is return value. Okay, so this T of n equal to 3 subrecursions returns 3 times 9th root of n plus root log n is added. Plus root log n is added. So apply master theorems by change of variables. Apply master theorem with change of variable, n equal to 9 power m. The T of n recursion converts to S of m. Okay, and this is become 3 times S of m by 9. 3 times S of m by 9 plus, okay, plus, see this value n equal to 9 power m, that means log n is m, this becomes root m. Okay, so if you apply master theorem, case 2 is true, it means root n to the power of log a, m to the power of log a base b multiplied with depth of recursion. Okay, so depth of recursion is log n base 9. So n is assumed 9 power m, n is assumed 9 power m. This is become theta of root, okay, root m is log n base 2, log n base 9, m is multiply with log m, okay. So this log m is log n, so that means it becomes log n. Okay, root log n multiply with log n is the written value, that is also correct. Okay, so answer to this question is BD. Yes, apply change of variable. So Chakrabarti, I am fine, watching video from IIT Jammu. So thank you so much. Okay, so those who already cleared GATE and joined in IIT still, okay, they are remembering us, it means a lot. Thank you so much, Chakrabarti. Okay. Is there any further explanation required? Okay, so time complexity equal to number of recursive calls here, because excess time taken by each recursion is constant. If excess time taken by each recursion, constant excess time for each subrecursion, okay, other than subrecursive calls, okay. So the total in this scenario, time complexity same as number of recursive calls. Number of recursive calls is complete ternary tree of log n base 9 levels. Complete ternary tree of log n base 9 levels. Okay, so that means t power log n, and it becomes, okay, so log n to the power of log 3 base 9. Log 3 base 9 is 1 by 2, right? So actually for time complexity no need to solve the recursion. Time complexity no need to solve the recursion. Okay, for time complexity, because excess time taken by each recursion constant. So time complexity, number of recursive call both are asymptotically equal. Number of recursive call asymptotically equal to time complexity for this question. Okay, because excess time taken by each recursion is only constant. So that's why for time complexity I didn't apply the recursion. Okay. But written value, this excess value is not constant. Other than subrecursions, excess value is not constant. Here you need to solve the recursion. To solve this recursion, better to go for change of variable now. Right? So these are the master theorem, recursive algorithm, finding time complexity, space complexity, number of recursive calls, and so on. Okay, so this is other important module. This is binary heap related question. Similar pattern question you might solve in the classroom questions and all. Okay, but this is the area where many people are doing mistake, because in the chart and all they use it to say explain this model again. Okay. So that means see the question, complete binary max heap. Okay, so given max heap, complete binary max heap is given. Okay, so the each integer, including each integer 1 to 2047 exactly once, the depth of a node is maximum. Okay, depth of a node in the max heap is largest path from root of the heap to the node. Okay, the root depth is 0. Then what is the difference between maximum and minimum depth? Okay, at which integer 127 can appear? At which integer 127 can appear? Maximum and minimum depth difference. See here. So try to understand one thing here. The given heap is max heap. So and integers are 1 to 2047. 127 he is asking, that means 127th smallest key, 127th smallest key, 127th smallest key. Of 2047 distinct keys. Right? Separately answer what is maximum depth and minimum depth. Instead of direct answer to the question, okay, what is maximum depth and minimum depth? Write the separate answers. What is maximum depth for this key and minimum depth for this key? Yes, going to take DBMS also tomorrow 6 to 8:30 or something like that, DBMS session tomorrow. Depth difference, okay, Sneha, not level difference. Okay, see in the max heap it is 127th smallest key. Okay, in max heap, okay, like assume 127th largest key, it's easy to visualize. So maximum it may go to the last level and minimum it can come to the second level, but max heap we need to think about the smallest key. Okay, so first of all 2047 is complete binary tree, 2047 keys. It means complete binary tree of 2 power 10 plus 1 minus 1. Okay, 2 power 10 plus 1 minus 1, height 10 and levels 11 levels. Okay, so height is 10 and 11 levels. Okay, so root level and the second level, okay, and third level, 10 height and 11 levels, right? Okay, so up to so on. Okay, let's say total 11 levels are there. Height 2 power 10 plus, okay, for height h 2 power h nodes, 2 power h plus 1 minus 1 for height h number of nodes at most 2 power h plus 1 minus 1 in binary heap. Okay, that means for height is 10 where I start from the 0, so height is 10 means it is total 11 levels, right? Okay, total it is 11 levels. Now so max heap means max key in the root, that is 2047 in the root. Okay, 2047 in the root. This 127 can be at the last level also. This 127 can be at the last level also, possible is there. Okay, so last level means what is depth? Okay, depth of that last node. Okay, so this depth is become 10 depth, right? Okay, depth is 10. Okay, so this node level 11th level means this depth is 10. That means maximum depth for key 127, okay, is 10th level, 10. Okay, root depth is 0, he says that 0, 1, 2 up to so on, depth 10. Okay, minimum how many levels? It's a max heap. So it may not come to the second level. Because so this is the 127th smallest. Okay, so these all descendants should be smaller. These all descendants should be smaller. Okay, so those many smaller keys are not there for 127. Okay, so that means then let's see the okay, so minimum depth. Okay, so minimum depth, see, this key should be at least okay. So if you think about the smallest key point of view, okay, so this should be at least bigger than two other keys because of max heap. Okay, so at least bigger than two other keys. For example, this key 1 here and key 2 here, then key 3 can here. Okay, so that means it can't be first minimum or second minimum key because two descendants are there. Okay, so similarly this also should be okay. For example, if you go for next upper level, okay, here for this 3 plus 3 6 descendants means this should be at least 7th smallest. At least it should be 7th smallest. Okay, less than that not possible because 6 descendants, 6 keys should be less than this, right? Okay, now if you go this one, 6 keys left subtree, 7 keys left subtree, 7 keys right subtree. If you go for previous level, okay, for this okay, this 15 plus 15, 30 descendants are there. This can be at least 31st smallest. Okay, at least 31st smallest key should be there here. Okay, so smaller than 31 can't possible here. Smaller than 31 because 30 descendants are there for this key. Okay, now if you go for next level, so these are 31 keys and these are 31 keys, total it becomes 62. This should be at least okay, so 63 smallest, 63rd smallest. Okay, because total 62 descendants are there, 62 descendants which should be smaller than this, minimum 63 smallest. Okay, 63 this also can be minimum 63 smaller keys, and this parent should be okay, this descendant 63 plus 63, 126 plus 1, 126 descendants are there. 126 descendants are there means it should be at least 127th smallest key. So 127th smallest key not possible to go, okay, so before this level, okay, not possible to go, so before this level not possible. After this level possible, 127 can go for last level also. So so minimum depth, if for example this is total 11, total depth is 10, okay, 10, 9, okay, so 10 depth, 9 depth, 8, okay, so 7, 6, and this is what depth here, depth is 5 here, okay, depth, okay, so this root 2 leaf, total depth is 10, okay, so 10 depth, this is 9th depth, and this is depth 8, depth 7, and depth 6, and depth 5, okay. So minimum depth for key 127, minimum depth for key 127 can be the 5 depth, right? Five or 6, okay, is it okay calculations? Okay, this is the depth 10, 9, okay, 8, 7, 6, 5. So maximum it can be depth 10 and minimum it can be, okay, so depth 5, minimum it can be depth 5. Depth 5 means it can be 6th level, if you take, maximum level, minimum 6th level, depth is maximum 10 depth and minimum, okay, 5 depth, okay. So the difference is 10 minus 5, okay. Got it? This much complexity not there if it is min heap, okay, if it is a min heap, okay, so 127 key can be at most at the last level, okay, 127th smallest even can come to the second level also, so maximum if it is a min heap, the key 127 can be at, okay, at most at last level, at least at second level, okay. So then, so min heap not a problem to deal with the smallest keys, max heap is easy to deal with the largest keys, okay. But this 127 is, okay, 127 key is close to the 127 smallest, but he is asking max heap, smallest in max heap, largest in min heap, okay, required to think properly, okay. So it's a numerical question, one small difference also total is wrong, right? So post your comment. Max heap you can easily deal maximum, okay, 127 largest or 10th largest or 31st largest, that is easy for max heap, okay. For min heap, okay, so 31 smallest, okay, so 127 smallest or 15th smallest or 10th smallest is easy for the min heap, okay. But when you deal smallest key in max heap or largest key in min heap, you need to think about properly, because this key, so this to satisfy max heap property, for this key, for this node total 126 descendants. 126 descendants means 126 keys should be less than this one. 126 keys, 127 sorry. 126 keys should be less than this one. So this should be at least 127 smallest. Okay, at least 127 smallest. 127 smallest can be beyond this 5th level, beyond this 5th depth. 5th depth to 10th depth it can be anywhere from 5th depth to 10th depth, okay, but it can't possible to come before, it not possible to come to the 4th depth or 3rd depth or 2nd depth or 1st depth or depth 0, okay. So hope you cleared this one, right. Next, data structure with n elements initially, data structures with, okay, one data structure with n elements. If algorithm required m times insertion, and m times key decrement, m times key decrement, and m times delete element operations. Algorithm required 3 operations, m times key decrement, okay, m times insertion and m times deletions. Okay, so for delete element and key decrement operation, okay, the pointers are given, means where to decrease, where to delete. The node means the address of the data is given, to perform key decrement and delete operation. Which data structure is preferred to implement, which is best data structure to implement the given algorithm. This is one standard model question. Okay, so don't feel like you are doing mistake and all. Okay, so I made the question such a way that it's more deeper concept. Okay, because simple question you already done so far. Okay, just to get the more concept and little, okay, bigger concept I included. So probably, okay, your answer might be wrong sometime. Don't get demotivated. Sandeep says min heap, Gauranshi says min heap, Sneha C is min heap, everyone saying min heap, Aman min heap. Right? Okay, for insertion, deletion, key decrement. Okay, insertion, deletion, key decrement. If you only require to perform insertions, deletions, key decrement. Key decrements. For these operations, insertion, deletions and key decrements, okay, these operations, okay, unsorted list or unsorted array is better. Unsorted array or unsorted linked list. Unsorted, either single linked list or double linked list is best, because if you go for unsorted list, insertion also constant time, deletion also constant time, key decrement also constant time. Okay, so one insertion constant time, m insertions become order of m time. Okay, one deletion constant time, one key decrement constant time, m key decrement is become order of m. One deletion constant, okay, so constant time, m deletion required order of m time. So unsorted lists are best. For insertion, deletions, key decrements. Unsorted lists are preferred for insertions, deletions and key decrement. These operations, unsorted lists are better. Unsorted lists are efficient. Okay, unsorted lists are efficient for insertion, deletions, key decrement. But so if delete min, delete max, find min, find max, those things are required. If delete min, delete max, find min, find max, those things are required, then unsorted lists are not efficient. Then unsorted lists are not efficient, right? So now if you go for sorted array, sorted lists are not efficient for these operations because of sorted order, one insertion takes log n time. M insertions become m log n time. M log n time. M insertions. Okay. One deletion required. Okay. What is again log n time? N time. M into n, not log n. Okay. So array shifting required, na? Array shifting required. One insertion required n time. Okay. Repeats m times. Okay. And one. Okay. So one key decrement also more time. Okay. So key decrement is also more time. So the order of n time required for one key decrement because you have to place in correct position, repeated m times. Then other one is this is insertion and key decrement. Deletion also it takes n time. Okay, even to delete you need to shift the elements. So deletion also m multiplied with n. Okay, so the sorted arrays are sorted lists are sorted arrays. Sorted lists are sorted array is not efficient for insertion, deletion, key decrement. Insertion, deletion, key decrement is efficient by using unsorted array or unsorted lists. Okay, min heap overall it is log n time. All three operations log n time. Insertion, key decrement, deletion all are log n time. So that means it become m log n. M log n plus again m log n. Okay, m log n plus m log n. Okay, AVL tree. So all are log n time, same thing only. Okay, so best data structure is unsorted single linked list. Even unsorted array also fine. Unsorted single linked list, even unsorted array also fine. Right? Okay, for insertions, deletions, key decrement, only insertion, deletion, key decrements are required in your algorithm. Only insertion, deletions, key decrements are required in your algorithm. Best data structure is unsorted linked list or unsorted array. Okay, but if delete min, delete max, find max, these things are required. Okay, delete min and find min, delete max, find max, these things are required. Then unsorted lists are not efficient. Okay, so hope you able to see the time complexity of all the various data structure for various operations. Okay, so much time complexity, so many operations related to this topic we done. Okay, so practice it. This is one frequent model area in examination. Right? Next, what is sum of heights of all nodes in the complete binary tree with n nodes? Sum of heights of all nodes in complete binary tree. Okay, there is a complete binary tree of n nodes. Complete binary tree of n nodes. Okay, like this. Like this complete binary tree of n nodes is there. What is sum of heights of all the nodes? Okay. Complete binary tree of n nodes. What is sum of heights of all the nodes in complete binary tree? ये भी गलत हो गया. Don't worry, the questions are made like that. Okay, so questions are made like that because you are attending live and spending time, so you need some quality questions na. So even if it is answer wrong, don't get demotivated. Can you please tell me instead of what is that comment, instead of max heap, here min heap. So here the previous question instead of max heap, if it is a min heap, instead of max heap, if it is a min heap, okay, then what the difference here? Okay, this question I think previous, I think this question only you are asking. If it is a max heap, instead of max heap, if it is a min heap, okay, in min heap, okay, so 127 key can be, see, min heap means, so root is key 1, 2, like this is key 2, key 3, like that. So key 127 can be at the last level also, okay, key 127 can be at the last level also, and at least it can come to second level also, because key 1 to 126 in left subtree, okay, and 127 can come here, then remaining keys in the based on the min heap condition, okay. Then if it is a min heap, so maximum depth is go to last level, minimum depth is the second level, okay, maximum depth is goes to last level, minimum depth is become second level. That means maximum depth is 10, minimum depth is become 2, minimum depth, sorry, depth is 1, second level, depth is 1, 10 minus 1, it become 9, okay. So until unless, so for example 120, see root is there na, root is there, okay, this is this left subtree of the root, should be 1023 keys, in the left subtree, and right subtree of the root is also 1023 keys, okay, and root is 1027, okay, so 1027th key, okay. So if this 127 is, okay, like this key, assume this key x, if it is bigger than 1023, then it may not come to the second level, okay, until key 0, key 2 to 1023, key 2 to key 1023 only na, 1023 keys, 24. So key 1 here, 0 1 here, so here this keys, okay, so 2 to 1023 keys means 2 to 1024, okay, 2 to from 2 onwards, total 1023 keys, okay, right. So until 1024, the key minimum can be at the second level, but if beyond it, then it may not possible to come second level, then it become close to the smallest, then close to the largest for min heap, okay. So like that you need to analyze for max heap and min heap for this question, okay. This is the frequent model used to ask in the exam, okay. Right. What is the sum of heights of all nodes in complete binary tree of n nodes? Vartika understood. Now okay, very good. Done this one? Anyone? Anyone done this one? Sum of heights of all nodes. Sum of heights of all the nodes in complete binary tree. B. Sneha, congratulations. Ashutosh. Okay. Now, so height of leaf nodes is 0. So in any tree, so height of the leaf, okay, height of the leaf node height is 0. Okay, so height of leaf nodes are 0. Okay, then this left subtree height, if h1, right subtree height, this left subtree node, root of the left subtree, root of the right subtree. Okay, so if this left subtree root node, if height h1, okay, assume instead of saying h, if height h, root tree height is h, then the second level node height is h minus 1. Second level node height is h minus 1. Okay, so maximum of left subtree height, right subtree height plus 1 is become height of the node. Okay, now root node height is become h. Root node height is become h. Right? Now, so let's do the calculation for height h. Okay, assume that instead of n nodes, let's assume height h. We convert height to nodes. Okay, see, number of nodes of each height. Okay, so height h node is one node. This node height h, height of this root node. Height of this root node is h. This node height h minus 1. Okay, so height h one node. So height h minus 1 two nodes. Height h minus 2 two square nodes. Okay, height 1 is 2 power. Okay, so 2 power 0, height h minus 1 2 power 1, height h minus 2 2 square up to so on. This node is height 0. Okay, so these are 2 power h nodes. This node height 1, left subtree height is 0, right subtree height is 0 plus 1 is become height of this node. Number of nodes 2 power h minus 1. This node height is 2. Height of this node is 2. Number of nodes of this level is 2 power h minus 2. Okay. Now, this is total number of nodes. 2 power h plus 1 minus 1 is the total nodes. 2 power h plus 1 minus 1 total nodes. But the question is sum of heights. Means if I add all these heights, height 0 only, 2 power h times 0 height, 2 power h nodes 0 height, then 2 power h minus 1 nodes, 2 power h minus 1 nodes, okay, height 1 added 2 power h minus 1 times, and 2 power h minus 2 nodes of height 2, 2 power h minus 2 nodes of height 2, okay, then here 4 nodes, 2 square nodes of height h minus 1, h minus 2, of each node height is h minus 1, 2 nodes of height is h minus 2 na height is h minus 2, this 2 nodes height is h minus 1, each node height is h minus 1, this root node height is h. This total sum of heights we want, total sum of heights, okay, total heights of this complete binary tree, okay. So 2 power h leaf nodes of height 0, leave this one, okay, leave this term, okay, anyhow 0 multiplication, 2 power h minus 1 nodes of height 1 and 2 power h minus 2 nodes of height 2 plus up to so on, plus 2 nodes of h minus 1 height and 1 node of height h. AGP series. In AGP series, the sum of series is leading term. 2 power h here, h here. So 2 power h is leading term. This is theta of 2 power h. That means sum of heights is in terms of 2 power h. Okay. So now but not for height h, for n nodes. In complete binary tree of height h, number of nodes is 2 power h plus 1 minus 1. That means total n nodes here saying total number of nodes 2 power h plus 1 minus 1 is n. Okay, that means 2 power h plus 1 minus 1 total nodes is equal to n. It means that 2 power h is order of n. It is n plus 1 by 2. N plus 1 by 2 is order of n. 2 power h is the height, sum of heights in terms of 2 power h. Okay, with respect to height h. Okay, if you compute this with respect to n nodes. Okay, 2 power h is in terms of order of n. Sum of heights of the complete binary tree of n nodes is order of n. Right? Sandeep, student of 2023 batch. Yes, this is equal to time complexity of constructing binary heap in bottom up approach, heapify method. Okay, that means the same question instead of saying that the sum of heights of complete binary tree, the same analysis is also time complexity to construct binary heap. This is also equal to time complexity to construct binary heap, min heap or max heap, binary heap, min heap or max heap, using heapify method, method for given n keys. Same analysis is equal to time complexity of sum of heights of all the nodes in complete binary tree. Okay, so sometimes only terminology can be different. Okay, analysis can be the same. Okay, so by the time of solving You should not remember like that. If you understood procedure, okay, the same sum of heights calculation, for complete binary tree is analysis for time complexity to construct binary heap by using the heapify method, right? So I think this question answered many, right? These are 2-3 questions of binary heap and that concept. Okay, so this is one of the repeated question in many competitive exams. So just see the meaning of question. Interesting question. Given n integers, the range is 0 to k. N integers whose range of these n integers is 0 to k. We wanted to pre-process input. Okay, you wanted to pre-process input such a way that any query about how many of the n integers falls in the range, okay, between x to y. Okay, so means between 2 to 5, how many integers exist in the array? Between 2 to 10, how many integers of n elements exist? Okay, so that should be answered in constant time. What will be the pre-process time? How much time required to pre-process n integers whose range is between 0 to k, such that you should answer how many integers falls in the range of x to y. You should answer that in constant time. Okay, means by the time of asking question how many integers between x to y, you should not scan whole array. Okay, you should answer in order of order of 1 time. To do this, how much total pre-processing cost? Options: n plus k, n into k, n. So Sneha n plus k, Yuvraj also A, Ashutosh is D. Right? Okay. See, for example, okay, so let's say range of integers, so 10 integers is 0 to 7. Range of 10 integers is 0 to 7. Okay. this is one given array, 10 integers. This 10 integers range is like maximum 7, minimum 0. Okay, so integer 6 also there, 4 also there, okay, or 3 also there, okay, 2 also may exist, okay, so 1, okay, so like this. No one is less than 0, no one is more than 7. Now, if I ask the question, how many integers between 2 to 4? How many integers between 2 to 4? So, if you scan whole array, you can find number of integers between 2 to 4, but it requires order of n time to scan it. Order of n time to scan it. But what he is saying that do some pre-processing for this array, so that you should be able to answer number of integers between x to y. Number of integers between x to y, how many integers exist between x to y, should be able to answer this in constant time. Answer this in constant time. To answer in constant time complexity. To answer in constant time complexity. So, how much pre-processing cost is required? Okay. So, here the one standard method here. So, initialize one count array. A of, let us say, count of C of 0, 1, 2, 3, 4, 5, 6, 7. So, count array of 7 elements. Initialize the one count array of 7 elements. Okay. So, initialize count array by zeros. Okay. So, that required order of k time. For I is 0, I less than equal to k, I plus plus. So, C of I initialized to 0. Then after that, so increase the frequency of each element. The frequency of 7 2 times. Okay, A of 1 is 7. Okay, increase count of 7. Okay, so 3, increase count of 3, and 6, increase count of 6, like a counting sort, similar to the procedure of counting sort. Okay, similar to the procedure of counting sort. So 2, increase frequency of this, frequency of 0 is 1, and frequency of 6 is 2. Okay, that required order of n time. This required order of n time. Run the loop from, okay, I is 1, I less than equal to n, I plus plus. Okay, so this A of I is become index for the count array. A of I is become index for count array, increase frequency of the count. Then it means the number of elements of 0, 1, number of elements of 1 is 1, number of elements of 2, integer 2 is 2, number of elements of integer 3 is 1. Okay, so if you add this sum with the previous count, that means count of 0 1. Okay, count of 1 is count of 0 plus count of 1 is 2. Now I can say the two integers less than equal to 1. Two integers in the array less than equal to 1. 2 plus 1, 3. Updating count again. 3 plus 1 is 4. It means 4 integers less than equal to 3. Okay, next this one 4 plus 2 is 6. It means 6 integers less than equal to 4, 6 integers only less than equal to 5. Okay, 8 integers, is there any count missed? Okay, count of 7 is also 2, count of 7 is also 2. right. So 10 integers is less than equal to 10. Okay, 10 integers is less than equal to 10. Okay, now this is the result of count array. This count of I represents number of integers less than equal to that key. For example, number of integers between 3 to 5, number of integers between 3 to 5, number of integers less than equal to 5 is 6, number of integers less than equal to 3 is 4. Okay, 6 minus 4, okay, so plus 1, okay, because this 3 included, okay, so that means count of 5 minus count of 2, okay, count of 5 means the number of integers which are less than equal to 2 should eliminate from less than equal to 5. That means count of 5 minus count of 2 is become integers between 3 to 5. Okay, so that means now if you want number of integers between xy, that means now you can say difference between count of x minus 1 minus count of y, count of x minus 1 minus count of y, count of y. These are the total number of integers which are between this, For this it required one more loop. For I is count 0 not changing anything, count 0 as it is. So I is 1, so I less than equal to k, I plus plus, just added count value with the previous. So count of I equal to count of I minus 1 plus count of I minus 2, count of I minus 1 plus count of I minus 2. Sorry, count of I minus 1 plus count of I minus 1 plus count of I is updated count of I value. So the total time complexity is, okay, so theta of n plus k, and space complexity also. Space complexity is, we used this count array, for this method theta of k. Okay. Yes, counting sort implementation except the last step, of the counting sort. Okay, except last step of the counting sort, remaining thing is the pre-processing cost. Okay, except last step to place the elements in sorted order, except that remaining things is the procedure. So answer to this question is option A, right? I think this question you can easily able to answer. Okay, just quickly answer of minute time. What is worst case time complexity of quick sort? To sort array of n elements by using pivot element is mid range. Mid range of given n integers, n elements. If pivot element is mid range, then what is time complexity of the worst case time complexity of the quick sort to sort the array? right? Yeah, mid-range is average of minimum and maximum. Mid-range is average of minimum and maximum. Okay. Mid-range is average of minimum and maximum. Okay. Now, average of minimum and maximum is a pivot. Partition may not divide into two equal parts. Partition may not divide into two equal parts. Okay. So, that mid-range can be close to maximum element. Mid-range can be very close to the maximum element rather than minimum element. So, in that case, okay, so the after one partition, it may not okay, divide into two equal parts. Okay. So, for example, these are the some array elements. Okay, let's say the array element is 2 is there, 10 is there. Okay, so 50, 500, 1000, okay, 5000, 10,000, 20,000. Okay, like that elements are there. Let's assume that 3,000. 1500. Okay, so 50,000. So average of minimum and maximum. Average of minimum and maximum. So minimum key is 2. Minimum key is 2. Maximum key is 50,000. Average is 25,000. So 25,000 element close to the 25,000. Element close to the 25,000 is okay. So 20,000 is close to the 25,000. So this is okay. So element close to the mid-range. Mid-range element is 20,000. If this kind of element is selected as pivot after one partition, only one key is greater. Okay. So only one key is greater than pivot. Okay, 50,000 one key is greater than pivot. If only one key is greater than pivot, so pivot is places at n minus 1 position. Okay, 20,000. Only one key is bigger than 20,000, that is 50,000. Okay, after one partition, n minus 2 elements become one subproblem. Okay, one element only in one subproblem. So partition cost is order of n time. So in this way, the worst case time complexity can become n square. Worst case time complexity can become n square. Right? Is this clear? Yeah, n minus 1 or n minus constant, the recurrence equation for worst case time complexity, T of n, one subproblem, T of n minus 2 elements, okay, and partition cost is order of n, finding mid-range is also order of n time to find mid-range, because we need to find minimum and maximum. So find mid-range is also order of n time. This is time complexity to choose pivot. Time complexity to find mid-range. And this is time complexity of partition. Okay, is the, if you apply substitution method, okay, so the asymptotic value is become n square. right? So divide and conquer questions is reduced that frequent from not that much frequently asking in last 4-5 years, but however quicksort, merge sort and binary search, 3 examples we can't ignore. So divide and conquer questions are little frequency reduced. Now they are more focusing about the notations, recursions and the graph and trees and like a graph traversal, spanning trees and those kind of questions. So divide and conquer and dynamic programming, the frequency is reduced of the questions after exam become MSQ. After exam, okay, includes MSQ question. So the frequency of divide and conquer questions and dynamic programming questions are reduced. Okay, so but still some examples of divide and conquer you must revise. Okay, so possibility is there, right? Now, so that's why I included. I think hope you are aware about this question. So I think this question not require explanation. Just answer this in half minute. What is worst case time complexity of quicksort of array of n elements using pivot is median of first, middle, last element. Pivot is median of first element, middle element and last element. First, middle, last element, okay, median is pivot. So this A of low, A of high and A of low plus high by 2. Okay, this first element, last element and this element, median of 3 elements is a pivot. Okay, so now the pivot is median of A of low, A of high, last element, A of low plus high by 2. Okay, this is A of low, A of high, A of low plus high by 2. So Sneha, really doesn't matter to choose pivot element from anywhere. So worst case time complexity remains n square. No, there are one specific case worst case time complexity n log n is median of n elements. If median of n elements is pivot, so pivot is median of n elements. Pivot is median of n elements. Okay, in this scenario, worst case time complexity of quicksort, is become n log n. It depends on question to question. You should not conclude like n square. But of course, this above question answer is n square. Okay, this question answer is n square. So because median of first, middle, last can be close to A of low or can be close to A of high. Median of first, middle, last, okay, can be close to A of low or can be close to A of high. Okay, so this also after partition, if this first element is first minimum, okay, so middle element is second minimum. Assume that middle element is second minimum, last element is third minimum. In that case, the median is become a median of 3 elements is become Z. Okay, then the partition become only one element is less than pivot. N minus 1 elements is n minus 2 elements is more than pivot. Only one element is less than Z, that is X. Okay, n minus 2 elements goes to other side. So worst case time complexity of quicksort. worst case time complexity of quicksort is n square. Worst case time complexity of quicksort is n square. Okay. Right. Now one merge sort question, because so even though it is a repeated question, okay, so I just wanted to remind quicksort, merge sort, don't ignore. So otherwise the frequency of divide and conquer examples are quite reduced from last 6-7 years. Okay, so last 6-7 years they are more focusing on graph based questions and tree based questions. Graph based questions and tree based questions frequency is increased, and asymptotic notation and recursions. Okay, and recursions and recurrence equations. So dynamic programming and divide and conquer, these two areas, okay, the frequency of questions are reduced from last 6-7 years. Okay, but however it's not completely ignored. Okay, so some dynamic programming examples of graph algorithms, especially graph algorithms of dynamic programming examples, which is Alpair shortest path algorithm of Floyd-Warshall and Bellman-Ford of the single source shortest path algorithm, as well as the matrix chain multiplication problem. Okay, so largest common subsequent problem, some of them is possibility to repeat, so but not required too much practice for, okay, divide and conquer and dynamic programming. Just go through the class notes, basic class notes, that is sufficient. Class test me, okay, right. D. So yeah, the quicksort and merge sort, all variation of questions I covered in class, right? So just go through the classroom notes questions. Classroom notes questions are sufficient. Okay, so we done too much deep analysis for quicksort and merge sort, okay, in session. So made easy either in both online and offline, both the platforms. Okay, so its classroom notes is sufficient. Just go through the classroom notes. No need to go too much deeper for divide and conquer and dynamic programming especially. Now, so because all are already covered in class. Now, this scenario is m sorted lists. M sorted lists. Each list n by log n by m elements. Each list log n by m elements. Okay. So of course these are sorted elements. Okay, because he is saying m sorted lists. Okay. So total m sorted lists are there. List star array no matter. So first log n by m elements. Log n by m elements in sorted order. Next log n by m elements. Log n by m elements in sorted order. These are also in sorted order. Okay, first list and second list up to so on. Okay, so log n by m elements is sorted order. These elements are also in sorted order. Okay, so like that total m subproblems are there. Okay, so m subproblems are there. What is time complexity to merge into single subproblem? Very simple shortcut. Time complexity of one pass. Time complexity of one pass. Total elements involved for the merging. Total elements for merging is time complexity of one pass. Okay, so total m lists. Each list and log n by m elements. Okay, so time complexity of one pass for two-way merging. Okay, if you go for standard two-way merging, standard two-way merge sort. Okay, so time complexity of one pass. Okay, is total number of elements in the list. Total number of elements for merging or sorting is, okay, so m subproblems, each subproblem log n by m elements, each subproblem log n by m elements. The time complexity of one pass is order of log n, order of log n. Then number of passes for two-way merging, log of number of initial sorted subproblems, log of initially m sorted subproblems, log m base 2. Okay, so log m base 2 multiply with log n, time complexity. Total time complexity of the two-way merging is theta of log n multiplied with log m, log n multiplied with log n. Right, this question I think almost all are answered, right? Let's move to the next question. How many BFS sequences possible for given graph? Okay, from source vertex is A. From A is a source vertex. If A is a source vertex, so how many BFS sequences are possible? If A is source vertex, how many BFS sequences are possible? Number of BFS sequences possible if A is a source vertex. So 288, 72, Sneha, Ashutosh, right? Okay, check it again. Okay, BFS traversal is level order traversal. So we need to traverse the graph level by level. Level order traversal, we will traverse the graph level by level. Okay, so how many levels required? See, A root, A adjacent, B, and A adjacent also C, A adjacent also D, and A adjacent is E. These are become second level vertices. Okay, these are become second level vertices, these four vertices. Then after that B adjacent and D adjacent. Okay, second level, these are the second level vertex. Second level adjacent is these two also second level adjacent. That means BFS spanning tree of 3 levels. BFS spanning tree of 3 levels. Okay, just draw the edges which is effect for BFS sequence. Okay, for example, if A is a source, okay, from A, C visited and E visited. So this edge not affect for BFS sequence. This edge not affect for BFS sequence because okay, by the time of this become cross edge. It's not a tree edge. It's not going to be not become a tree edge. Okay. Now A adjacent C and B already visited. This edge also not affect. This edge also not affect for BFS sequence. This edge also not affect is BFS sequence. Okay. Eliminate those edges to avoid confusion. But FG B adjacent also FG and D adjacent also G. Okay, that means this FG is adjacent of both BD. F and G both adjacent of B. Okay, D adjacent is only G. Okay, and FG is not affect for BFS sequence. This FG is not affect for BFS sequence, but these three edges, all three edges are not tree edges. One of them is become cross edge, but okay, but if B visited before, then FG and GF can be visited. If D visited before, okay, GD and okay DZ can visit in third level. Okay, F is after that. Okay, but this edge is not affects. Similarly, this E adjacent also, okay, I and H, E adjacent also I and H, D adjacent also I. Okay, again this edge also not affect for BFS sequence. This edge is not affect for BFS sequence. Okay, just I am taking the edges which are affect for BFS sequence. A visited first, A adjacent is, it's not BFS spanning tree, it may be more edges than spanning tree, only edges which are affect for BFS sequence. Okay, that means BD, okay, BDE and C. All four are adjacent. Next, B adjacent is FG. Okay, then D adjacent is G, right? D adjacent is G. Okay, B adjacent is FG and D adjacent is D adjacent, D and G and okay, so G only, right? Okay, D already completed, D already visited. Okay, now similarly D adjacent is GI. Okay, D adjacent is GI, G as well as I. That's what I say, it's not spanning tree because it's from loop. It's not spanning tree of BFS. Only edges subset of graph, subgraph which is affect for BFS sequence. Okay, BFS sequence, eliminating remaining edges. Okay, so D adjacent is G and I both, and E adjacent is I and H both. And no one is C adjacent from the third level. No one is C adjacent. Okay, so these four vertices can visit any order. B, C, D, E is 4 factorial ways. But next 4 vertices of third level sequence depends on the second level sequence. That too not affected by C but affected by BDE. Okay, based on BDE sequence FG, HI. Okay, so for example, if B before D and E and FG or GF can be visited any order. Okay, so E before B and D, then IH and HI can be visited any order. D before B and E, GI and IJ can visit any order. But G is also adjacent for B and I is also adjacent for E. Okay, now see, if BE or EB, okay, so B first then E, or after that D, or E first then B, after that D. In that case, these two vertices 2 factorial ways, third level 4 choices for this. This is BDE or BED. Okay, if these two, A is the first vertex, A is the first vertex. So if for these two choices FG and GF, two choices, and IJ, IH and HI is two choices. Total it become 4 ways. Here also 4 ways. Okay, here, okay, so B, not BDE, BED. Okay, BED, EDB. I written wrong here this sequence. EDB. If B before B, D and then B, E and then D, or E, B and then D, then 4 ways. 4 ways. But okay, if anyone come before, one of them come before, it means for example if B before, then FG or GF. Okay, after that if D occurs, then only I is not visited. After that if E occurs, only H is not visited. That means if D is not if D is not after BE, if D is not after BE, okay, if D is not after BE, okay, like this, right? If D is after BE, then these are 4 ways and these are 4 ways. Remaining things, remaining sequences, okay, so BDE can be 3 factorial ways. 3 factorial ways for BDE, remaining 4 sequences of BDE, okay, then FGHI is 2 ways only. FGHI is 2 ways only, okay, because for example one of them is BDE, one of them if BDE, if B before, then FG, GF, FG and GF. After that D adjacent is G already done, only I. Okay, after that E adjacent, I already done, only H. That means FG, IH, GF, IH, 2 ways only. So remaining 1, 2, 3, 4 is 2 ways. Okay, these are 2 ways and these are 2 ways and these are 2 ways. Right? So that means 8 plus 8, 16 ways. 16 ways except the C. 16 ways except the C. C is okay. C, based on the position of C, third level what is not affected, but C can be anywhere in the second level. C can be anywhere in the second level. That means C can be here also, or C can be here also, or C can be here also, or C can be here also. So for this 16 possibilities, each possibility 4 positions for C in BFS sequence. Okay, so 16 multiplied with 4. Okay, so that's 64, right? 64 BFS sequences possible. 64 BFS sequences possible. Okay, Ashutosh answered correctly. Right, done this one. So BFS sequences counting, number of BFS sequences, okay, counting of number of BFS sequences is also okay one feasibility of numerical question here. Next simple question only, direct question. Okay, so let the given directed graph G, suppose an edge UV such that, okay, so distance of U, D of U less than, not distance, D of U less than, D of V less than, F of U V less than F of U. Okay, so now where D of I is exploration begin, F of I exploration finish, sequence of DFS traversal from source S. Okay, so the edge UV must be the edge UV, if this is the sequence, exploration, finishing and okay begin order of UV, this sequence, That means U starts, then V starts, V finishes, then U finishes. For this sequence, what should be this UV edge? What should be the edge of this UV? Please explain what is this. Last C. In this, until this I didn't include the C, excluding the position of C. If you exclude the position of C, then total 16 ways. Okay, in 16 ways we didn't include the C, but C is also one of the vertex. C is also one of the vertex, and that too in BFS sequence it should be in second level. It should be in second level means it should be after A, before FGHI. C should be after A, before FGHI. That means C can be after A, C, B, E, D also okay. And C can be here, A, B, C, E, D also okay. C can be here, A, B, E, C, D also okay. C can be here, A, B, E, D, C also okay. It should be, because it's a second level vertex, okay. It should be after A, before FGHI. So before including C means if I exclude the C, total 16 ways, where the C is one more vertex in the second level. C is one more vertex because position of C is independent of third level vertex. No vertex at the third level, no vertex of third level in BFS sequence. The BFS spanning tree third level vertices are not adjacent of C. Okay, that's why C not included before. Okay, so but C can be anywhere from second level to fifth position, second position to fifth position, anywhere C can exist. Okay, that's why for each of the 16 possibilities, okay, so 4 multiplication of positions of the C. Okay, right. Now back to this one. It is easy question only. Let me see how many answer correctly. Forward edge. MSQ question. MSQ question. Right. So options: Ashutosh C and Sneha C and Vartika's also saying C. Right. Okay. Not just forward edge, it can be tree edge also. Tree edge and forward edge both sequences are same. Tree edge and forward edge both exploration, finishing and ending order is same. Okay. So in DFS spanning tree, assume this is DFS spanning tree. Okay. It is DFS spanning tree of A, B, C, D. Okay, so and this forward edge sequence and tree edge sequence both are same. So that means if U and V, that means, okay, if it is a tree edge, U begins and then V begins, discovers U, discovers V, and after that finishes V first, okay, finishes V, and then backtrack and finishes U, backtrack and finishes U. And forward edge also same, discovers U and discovers V, okay, and finishes V and finishes U. Both are same sequences. Back edge, okay, so back edge, if descendant to parent edge is there, if descendant to parent edge is there, U and V, okay, this become U and V. Now this V, okay, so U to V, V discovers first, then U discovers, then U finishes first, finishes U, and then finishes V, is the back edge sequence. The cross edge sequence, like this kind of edge is the cross edge sequence of UV. V discovers, okay, discovers V and finishes V, discovers V and finishes V, backtrack and come to other path, and then discovers U and finishes U, okay, is the cross edge. The sequence is true for both tree edge and forward edge. The same sequence for both tree edge and forward edge, right? Yeah, test series, this kind of question definitely include in test series because it's one important model to understand, okay, it's discussed in the class also, okay, it's guaranteed, okay. So see, in MEDIZ OTS it's a part 1 subject level, part 2 subject level, single subject test, and FST 1 to 8 mock, okay, so 1 to 4, okay, so approximately in total, okay, all tests, okay, more than 170-180 questions, more than 170-180 questions means almost every topic get covers, okay, almost every topic should cover, right? So almost 180 questions from one subject, okay, so like that, same thing for all other subjects also. So complete the test series, at least FSTs, okay. Next, let A of n denotes the number of n bit binary string, number of n bit binary string, A of n denotes number of n bit binary string. This is, okay, maybe DA people may feel difficult for this, okay, because it's a dynamic programming, okay, so just okay, it may not be that easy for DA students, but CS students should be able to answer this, okay. A of x denotes the number of n bit binary strings which have no pair of consecutive ones, binary strings no pair of consecutive ones, okay. The time complexity of the efficient algorithm which uses dynamic programming computes A of n, okay. So number of binary bits, number of binary sequences, binary bits of n, binary sequence of n bits, such that there should not be any consecutive ones, okay. It can be consecutive zeros is okay, or 1 0 0 1 also okay, but consecutive ones should not be there, 1 1 should not be there. So how much time required to calculate this? Option B not same sequence, na? Option B not same sequence for this, okay. Discover V discovers U, okay, here discovers U discovers V, discovers U discovers V, here discovers V discovers U, A and B not same sequence, this sequence is not B, it is only A, and that too it is a directed graph, U to V and V to U edge not same, okay, U to V and V to edge U not same, because it is a directed graph. Because of this directed graph, U to V and V to U is not same, okay. So So if it is undirected graph, definitely, okay, so edge UV is same as edge VU, okay. So then that's the reason for undirected graph of BFS sequence, okay. So only tree edges, okay, this edge and this edge both are considered as a tree edge, okay. There is no back edges, there is no cross edges, and forward edges, only tree edges and back edges, okay. So for undirected graph this sequence is different, right? So because of directed graph A and B both are not same sequences. Now right, so it is easy question only, this one is easy question only, okay. So n bits are there, for example 1 bit, T of n denotes number of okay, n bit binary string, n bit binary string which may not consecutive ones, okay, so not may not, which have no pair of consecutive ones, okay. So if one bit is there, n equal to 1 bit is there, so two sequences, okay, 1 or 0, no consecutive ones na, so two sequences, T of 1 is two sequences, that is, okay, either 1 or 0, okay. T of 2 bits are there, so no consecutive ones, means three sequences here, that is 0 0 0 1 1 0, three sequences which doesn't have consecutive ones, okay. So T of 3, okay, T of 3 no consecutive ones, if no consecutive ones, see, so this three sequences of T of 2 with pad 0 as a most significant bit, okay. So 0 0 1, okay, 0 1 0, okay. So previous question, most significant bit if 1 is there, then don't pad 1, if most significant bit 0, so pad 1 to the most significant, those are two more choices, that means 1 0 0 1 0 1, 5 sequences, T of 2 3, so sorry, T of 1 2, T of 2 is 3, T of 3 is 5, right. Now so T of 4, if you think about T of 4, okay, these 5 sequences add most significant 0, these 5 sequences add most significant 0, okay, is also the answer to this one, 0 0 0 0 0 1 and 0 1 0 1 0 0 and 1 0 1, okay, most significant bit is 0, these are, okay. So 5 ways, and except this most significant bit 1, these two cases, these three cases you can pad 1, okay. So that means 1 0 0 and 1 0 0 1 0 0 0 and 1 0 1 0, okay, total 5 plus 3 8, 5 plus 3 8, which doesn't have consecutive ones, okay. See, T of 1 is 2, T of 3 is 3, okay, 2 plus 3 5, 5 plus 3 plus 5 is 8. If you observe the recursion, so T of n is T of n minus 1 plus T of n minus 2, okay, for n greater than 2, for n greater than 2, okay, and for n equal to 2, okay, n equal to 2, 3 choices, base condition. For n equal to 1 is 2 choices is the base condition. So this is the recurrence equation to solve this problem using dynamic programming. Implement this recurrence equation so by avoiding recomputation. So on and when t of 1 calculated, on and when t of I calculated, store in array, okay, on and when t of I calculated, store in array, and so by reusing, and you can calculate in order of n time. So if you want to implement algorithm for this, okay, to implement algorithm for this, so we can do like this, okay. So consecutive ones we want, so algorithm simple, okay, of n bit string is given, okay, and length of the binary bit sequence is n, okay, base condition. So initialize the, to avoid recomputation, take one extra space. For I is 0, I less than equal to n, I plus plus, okay. So let's take this number count of the number of binary bits is initialized to 0, and okay, this is extra space, okay. So not required to initialize the whole array by 0 also, not required to initialize whole array by 0 also, just initialize the base condition, just initialize the base condition, extra space required, initialize this base condition. So this base condition is, let's assume C of 1 equal to 2 and C of 2 equal to 3, okay, this base condition is directly initialized, and compute in bottom up approach. Compute, okay, 1 and 2 is already calculated, so I is runs from 3 onwards, so I less than equal to n, I plus plus. By the time you are calculating a of 3, okay, C of 3, count of 3, so count of 3 equal to count of 1 plus count of 2, count of 4 equal to count of 3 plus count of 2, that means C of I equal to C of I equal to C of I minus 1, C of I minus 1 plus C of I minus 2, C of I minus 2, okay. So something like this, it is reusing previous calculated part. Return the final value, return C of nth value, okay. This is the dynamic programming implementation to solve this above problem. So time complexity is just one loop is used, time complexity is order of n, and we also used extra space, okay, extra space is used, okay, so to avoid the recomputations, okay. So time complexity is order of n, as well as space complexity is also order of n. Right. So hope you cleared this one. Next, I think you can able to answer this. Number of spanning trees, is it required to solve? So solve this question later. Okay. I think answer is 40. Okay. So if any issue of calculation this, okay, so please send message to me, then I will share the solution of this. Okay, so because of time, then I'm just giving this as a practice question. Next, let's move to the next question. Try this one. if x represents, this one graph is given, weighted graph is given, x represents number of minimal cost spanning trees of the graph, number of minimal cost spanning trees of the graph, y represents number of second minimal cost spanning trees, second minimal cost spanning tree, that means spanning tree whose sum of edge weights less than all spanning trees except the actual minimal cost spanning tree, means second highest spanning tree, second minimal cost spanning tree. What is mean by second minimal cost, he explained. Okay, then x and y, x is the number of, okay, so minimal spanning trees, y is number of second cost minimal spanning trees. What is 2 power x and 2 power y difference? 2 power x and 2 power y difference. Try this one. Okay, now first, how many MSTs, how many minimal spanning trees, MSTs. Okay, MST means, see, this both min cost edges not forming the cycle, both min cost edges not forming the cycle, that means this A to G, A to G and G to F both are not forming the cycle, so both are in MST, and remaining 2 edges required for this subgraph, 2 edges required out of 3 edges. Okay, so all are edge weight 2 only. Okay, all these are edge weight 2 only, and 2 edges required out of 3 edges. So all are edge weights 2 only. Okay, so these 3 edges you can choose any 2 edges, that is 3C2. These 3 edges you can choose any 2 edges, is 3C2. Okay, so total 6 MST is possible. 6 MSTs. Okay, minimal cost spanning trees. Now second minimal cost spanning trees. Okay, second minimal cost spanning tree means, so second highest MST whose edge weights is more than MST. Okay, so second highest MST. Okay, so this edge is, okay, if this edge is included, you should exclude this edge. Okay, if you exclude, okay, because if you also include this edge, that become MST. Okay, if you exclude this edge, then 1, 2, 3, 4, 5, 6. Out of 6 edges, he has to choose 5 edges. Out of 6 edges has to be choose 5 edges. Okay, so 5C, okay, 1, 2, 3, 4, 5, 6, 65. 65 is 6 ways. Okay, so out of these 3 edges and these 3 edges. Okay, out of these 3 edges and these 3 edges, total 6 edges. Out of 6 edges, you need to choose the 5 edges. Okay, 65 and plus this one edge. Okay, so now this is the 6 choices. Similarly, this one included, this one excluded. Then again 5 edges out of the 6 edges. That means total 10, 5 plus 5, 5 plus 5, total 10. Okay, second highest minimal spanning tree. Second highest MSTs. Okay, so X is minimal spanning trees. Okay, so 6 minimal spanning trees. Y is second highest minimal spanning tree. Okay, 66, sorry, 6 plus 6, na? So 12. 6 plus 6, not 5 plus 5, 65, 6 plus 6 is the second highest. MSTs are 12. Okay, 12 are the second highest minimal spanning tree. Then 2 power X is 2 power 6 minus 2 power, okay, 3 into 3, 9, this is 9. MST is 9, 3 into 3, calculation mistake. So MSTs are 2 power 9. MSTs are 2 power 9 and second highest MSTs are 2 power 12. So 2 power 12 it is, okay, so 2 power 11 is 4028 minus 512. 4028 minus 512. Okay, so is the difference. So how much? So MSTs are 2, second highest minimal spanning trees are, okay, second highest minimal spanning trees are, okay, so 12, minimal spanning trees are 9, minimal spanning trees are 9, second highest minimal spanning trees are 12, 2 power 9 minus 2 power 12. So do the calculation. So 3584. Okay, so answer to this question is 3584. So here important thing is finding number of MSTs of the given graph. If edge weights are not distinct, MST of the graph may not unique. Even edge weights are distinct, second highest MST may not unique. If edge weights are distinct, second high minimal spanning tree is unique, only one MST is possible, but even edge weights are distinct. If edge weights are distinct, then X's become 1, Y may not be 1, Y can be more than 1. Okay, so got it. So this concept, this kind of numerical questions which are related to counting number of MSTs or counting number of second minimal cost MSTs, etc. Okay, any doubt on this? Please post your comment. For MST also we choose 64. No, for MST not 64 because these two edges are added, because these two edges are already included for MST. For MST this A to Z, G to F already added. Because of these two are added, one of these three edges required, sorry, two of these three edges required. Among these three edges required two edges. Because I can't take all three edges, it will become cycle. Okay, two of these three edges required. Okay, from these three edges, any two edges you can choose. From these three edges, any two edges you can choose. That become 3 into 3 is become 9 MSTs. Okay. Which of the given statement is are true for the undirected graph G with distinct edge weights? Assume number of vertices more than 5. Number of vertices more than 5. Not like a 2 vertex graph, 3 vertex graph and on and like that. Okay. Now edge weights are distinct, undirected graph and distinct edge weights. Distinct edge weights. Next, min cost edge and second min cost edge of entire graph must include in MST. Third min cost edge of entire graph, okay, excludes in MST. Then fourth min cost edge of G must includes in the MST. Means if third min cost edge is excludes not in MST, then fourth min cost edge must include. Okay. Next, third and fourth min cost edge of the graph must include in MST. Both third and fourth must include in MST. Okay. Both third and fourth min cost edge of the Z may excludes in some MST of the Z. Answer this. Okay. So min cost edge and second min cost edge of entire graph must include in MST. Must include in MST if distinct edge weights. Okay. If third min cost edge excludes, which can form cycle with first and second minimum, then fourth min cost edge must include in MST. Okay, there is no chance of both third and fourth min cost edges of the graph must include in MST. Okay, so it may not be true for both can be included. Okay, so okay, because if third min cost edge is not form cycle, then fourth min cost edge can form cycle with 1 2 3 minimum cost edges. If 1 2 minimum cost edges, if third min cost is okay not form the cycle, then fourth min cost edge includes. Okay, so both must include may not be every time. Okay, must include in every time not occurs. Okay, so it depends on graph. Okay, if in case first min, second min, third min, fourth min, all four min cost edges, first min to fourth min, all four edges, okay, is not form the cycle, then it includes the so both. Okay, but there may be a chance that first and second minimum can form cycle with third minimum, or there may be a chance that first, second, third minimum can form cycle with fourth minimum. Then in that case one of them has to be excluded. Okay, so then both excluding is also not possible. Okay, not possible to exclude both of them, means okay, if third minimum includes, fourth minimum may exclude. Third minimum, okay, so excludes, fourth minimum includes. Okay, so there is no chance of both are excluded. So for example, if you take the graph with more vertices, okay, okay, so 4 or 5 vertices or more than 5 vertices, like this kind of graph. Okay, so first mean cost edge and second mean cost edge. Okay, and if third mean cost edge is here, third mean cost edge is here, then third mean cost edge excludes, then this third mean cost edge excludes, and if third mean cost edge excludes, wherever it is fourth mean cost edge, that is not here, that is not here. So it can be anywhere outside of these three edges only. Okay, so that's why fourth mean cost edge should include now. Fourth mean cost edge should include now. Now fifth mean cost edge can form cycle. Fifth mean cost edge can form cycle. Sixth mean cost edge can form cycle. Okay, then the may excludes now the fifth minimum and sixth minimum. Then seventh minimum, fifth and sixth minimum excluded. Fifth and sixth minimum excluded, and third and fourth one only includes. Out of third and fourth one only includes, fifth and sixth is excludes. Okay, then seventh minimum is come into the MST. Then seventh minimum like that edges are there, I assume that. Okay, but there is no chance that both third and fourth can be excluded. No chance that both third and fourth can be excluded, right? So answer to this question is AB. So two more questions. Should I give answer or explain? What is time complexity of Kruskal's algorithm to construct MST of given simple directed weighted graph with n vertices and e edges by using sorted single linked list? Okay, so the sorted single linked list used as a data structure. If sorted single linked list is used for Kruskal's algorithm. Okay, for Kruskal's algorithm, instead of using the bin heap, sorted single linked list is used to choose greedy selection of the edge weight, next mean cost edge weight. Then what is time complexity of the Kruskal's algorithm? Time complexity of the Kruskal's algorithm. So what we do in the Kruskal's algorithm? What we do in the Kruskal's algorithm? Okay, so choose mean cost edge. Okay, choose mean cost edge UV. Okay, if UV not forms cycle in MST, okay, then add UV into MST. Okay, repeat this again, choose next mean cost edge. Okay, repeat until MST n-1 edges are, okay, all E edges are selected. Okay, now to choose this mean cost edge, he is saying that sorted, okay, single linked list is used. Okay, sorted single linked list is used. Okay, now so it means that if you go for sorted single linked list, so just, okay, before this, okay, so before this step, build sorted list for all edges, build sorted single linked list for all E edges. For all E edges, build the sorted single linked list. Okay, sorting required for E edges in ascending order. It required order of E log E time. Order of E log E time. Sorting E edges. Once you sorted edges in ascending order, then delete min. Choose the extract minimum or delete minimum. Required constant time only. Extract minimum is required constant time only. This repeats. Okay, this repeats order of E time. This repeats order of E time. The build sorted linked list required order of E log E time. Then total time complexity of the Kruskal algorithm. Total time complexity of the Kruskal algorithm is become order of E log E. Order of E log E. Because E log E not in the options. Okay. So log E and N not asymptotically equal. Because edges can be at least order of N, at most order of N square. E and N not asymptotically equal. But log E and log N asymptotically equal. Log E and log N asymptotically equal. You can write E log N also. You can write E log N also. Okay, because so edges are for connected graph. Spanning tree means this should be connected, otherwise spanning tree is 0. Okay, no spanning tree. Connected graph means order of E, order of N, minimum edges. So maximum edges are order of N square. So E and N asymptotically not equal. E can be order of N square, N is okay, what says, okay, but log N and log E asymptotically equal. So the answer to this question is E log N. E log N. Option A. Okay, E log N, but not N log E. N log E false. N log E is false. Best case can be N log E. N log N is best case. So worst case is N square log N. Worst case N square log N, but not always N square log N. Okay, for example, the same question he is asking, what is worst case time complexity? What is worst case time complexity? You can say E log N also or N square log N also. E log N also or N square log N also. Maximum edges are order of N square. Maximum edges are order of N square. But best case can be N log N also. Best case can be N log N also. So the BCD is not correct answers. Right? Okay. So next two questions, just try it. Okay, try the next two questions. Okay, closing session because already 3 hours. Okay, I think next one question only. So how many possible permutation sequences for keys 1, 2, 3, 4, 5, 6, 7? How many possible permutation sequences for keys 1, 2, 3, 4, 5, 6, 7 can be insert to result this given binary search tree to become this BST, to become this BST. So how many possible permutations you can insert? Okay, what are number of permutations of keys? Number of sequences of the keys. Permutation means sequences. Number of permutations of keys 1, 2, 3, 4, 5, 6, 7. So that you should get this resulted BST. Okay, so is it required explanation for this? I think if you know, I will skip this. Okay. So first we need to insert 4, otherwise okay root can't be 4, no? It's not rebalancing and all, just a normal BST, okay, not like a rotations and all considered here, okay, normal BST, because if rotations are considered we can't say, okay, so exactly, okay. So now every permutation can become this are some, okay, rotation nothing is considered, assume that, okay. So this sequence is there. First key should be 4. First key should be 4. Otherwise, root not become 4. That means this result should be this tree to become this resulted tree. In the resulted tree, okay, a root should be in the resulted tree. Root should be okay 4. That means first key should be 4. And these 3 keys, out of these 3 keys, 2 should be before. That means 2 1 3 sequence also okay, 2 3 1 sequence also okay, okay, these 3 sequence, these 2 ways, okay. Then out of 6 7 5 6 7, 6 should be before, because 6 should be parent of 5 7. 1 6 inserted, then okay, so 5 7 also okay, or 1 6 inserted, okay, 7 5 is also okay. These are 2 sequences, okay, 2 permutations. But here this 2 3 2 1 3 can interleave, this 2 1 3 can interleave any of the sequence of 6 5 7, okay, 2 6 5 7 1 3 2 1 6 5 7, any sequence, okay. These 3 should be same order, these 3 should be same order, but these 2 can interleave, 3 plus 3, total 63, okay, 6 elements, out of the 3 should be in the same sequence, 3 in the same sequence means 63, okay. Now like that, how many combinations are there? This 3 can interleave with this 3 sequence, or this 3 can interleave with this 3, okay, again 63 choices, plus, or these 3, this sequence can interleave with this sequence, again 63 choices, and this sequence can interleave with these sequences, again 63 choices. So total 80 permutations, 63 is 20, total 80 permutations to become this resulted tree, okay, right, very good, Sandeep. Yeah, this is about algorithm GTQ. Hope I covered almost all, okay, topics, so except a few examples of dynamic programming and all, okay. So this is all about the GTQ session of the algorithms. So if any further doubts or further classification, anything required, feel free to message, okay, in WhatsApp. Okay, for any preparation related things or any guidance or anything required, okay, so feel free to message, okay. So all the very best for your examination. So definitely you have a little tense, but it's a part of the competitive exam, okay. So this next upcoming, I think it is around 8 plus this 15 days time is there, utilize this 15 days, okay. So just give the 10 more days, you can give the FSTs, last 4-5 days stop giving the FSTs, okay. So complete your FSTs before 3rd or 4th of the February, last 3-4 days, and just keep revise the things, okay, basic formulas and basic concept and short notes or full notes, whatever it may be. So but because if last exam before one FST is given, see in FSTs what happened, some topic, so some tests can be more difficult questions, then you may get less marks. Some tests can be less difficult questions, you may get more marks, okay. So in case the last 1-2 FSTs, if you get less marks, you may get demotivated, okay. So that's why the complete your FST concept or giving FSTs of the test series, mock test and FST tests and other things, and before the 4th and give made easy Anubhav test. So in means in Medici website also shared the link of Anubhav test. It is conducts in almost all major cities, and you will get the like equivalent to the exam feel. Okay. So if any further requirement, please feel free to message me. Thank you so much. This is all about GTQ session of the algorithms. Take care. Bye.
Should I start?